Hi, my name is Ines. As you've heard, I'm a software developer from Slovenia, and today I'd like to talk to you about software estimations. So I've been writing code for almost 2 decades now, which means that for almost 20 years, people have been asking me the same question: how long will it take? And over the years, I think I went over all of the various permutations of trying to conquer this beast of software estimation, right? But no matter what I tried, it all just felt like a game of guessing. At the beginning, I really wanted to give the true answer, like a good number, but none of the techniques really worked. And I know that that's not necessarily the consensus among developers. I know there's a lot of developers out there who are like, I'm really good at estimating, and this is not a hard thing to do at all. But there is actually research on this topic, and research suggests that developers are horrendous at estimating. So I decided to travel the world and talk about it. So let's get into it. So unfortunately, it turns out that you will never be able to accurately estimate the time and effort it will take you to build a piece of software. For as long as you keep building new things, it is just a fact of life that estimates are based on past experience, and new projects, by definition, are not past experience. If I came up to you and said, can you build me this vase, and how long do you think it will take you? But you've never built a vase before, so what can you really answer? I don't know. Well, okay, but then I say, I'll give you a spec, 20 pages, exact specification, how high it has to be, how the patterns have to be, the colors, everything. Will you be able to estimate now? Or what if I say, I'll give you 3 more people? How long will it take you now? Turns out that the spec or the people or whatever, that's not really helpful at estimating, right? Since you've never done it before, the true answer is still, I just don't know. The unfortunate truth is that you can only estimate projects that you are very familiar with. And only if they're done by a team that you are also very familiar with, right? And also if the circumstances under which this is happening is also something that you're very familiar with. The unfortunate truth is, however, that most of the time we are not very familiar with any of these things. And so it has been known since the 70s that developers tend to give very optimistic estimations. And nothing has really changed since then. One of the reasons that nothing has changed is that developers rarely track the actual time that goes into building a thing. We do the estimates, but then the estimate kind of just disappears into the void. We never compare it to the actual work, and so we cannot get better at it, right? Because if you don't track, then you cannot know where the estimate went wrong, right? And you cannot get better at estimating, because you have no clue what was right and what was wrong. It's like if you were competing in archery, you would shoot your arrows, you would never look at the targets. You just know that at the end you were on place 25. This is just how it happened. But then another reason for optimistic estimates is that the way how we do estimates. We often like to do estimates. We take a project, we split it up into subtasks, and then we estimate each subtask. And then we do the crucial mistake of just summing up the number, which is problematic because it is nearly impossible to come up with a complete list of every single thing that needs to actually be done for this feature to reach your customers or users. We especially tend to forget unexpected problems. So things that are often called unknown unknowns, things we just don't know will be a problem until we are staring them down at some future point in time, right? Because there is a big difference between the gist of this feature is working on my computer and it has actually been deployed to users and the users are actually using it. So let's look at some research now. Here's a paper with the lovely title, Better Sure Than Safe. The researchers set out to look at overconfidence in software effort estimations. So one of the first tasks they did was go into companies and find old projects that had the original estimate and also the actual effort that went into building this project. But it turned out to be very hard to find projects with this information. So projects with the estimate and the actual effort. They went into 6 companies, They looked at more than 100 projects. They found that 30% of the projects did have an estimate. However, only 3 projects out of the 100 had actual effort recorded. And even these 3 projects had the effort recorded in a way that made it quite difficult to compare to the actual estimate, which already somewhat explains then the overconfidence the researchers found next. Because feedback is essential at learning and improving. There's one exercise that I really adore in this study, and I find it really well illustrates how we are not that good at estimating. So they went into this one organization and they collected 20 software professionals, so not developers, software professionals, people who work with software. And they put them into 4 teams. They got 1 project manager, 1 software developer, 1 designer, and 1 customer success person. Out of these 4, the developer and the manager were thought to have like the technical know-how of how to actually deliver the project, whereas the other 2 would focus on people, right? Either users or customers. And then they took an old project of this organization, a typical project, not something out of the ordinary, just a very, very typical project for this organization. And this typical project had an original estimate of 1,240 hours and the actual effort of 2,400 hours. So as we can see, already 100% over time, right? And they asked the original people, did something go wrong? What happened? And they were assured, no, everything was fine. This is just how the project went. I don't know, that's just how it happened. It's important to note that the researchers paid the company to participate in this so that the people actually felt like they have time to spend actual effort and thinking about the project and coming up with a great number. So next, each participant was asked to estimate the project, first individually and then in groups. And these numbers are the numbers of what the groups estimated. So as you can see, all the numbers are very optimistic. All of them are below of what the actual effort was. Only the highest number came anywhere close to the actual effort. And you might look at the highest number and say 2,250. That's almost 2,400. That's not that bad. But I would like to emphasize that 150 hours, that is almost 1 person, 1 month of work. So that is not a negligible time to spend on a project. And again, this was a typical project for this company. This was nothing out of the ordinary. Now let's look at the individual estimates. You can see them in this table, but not all of them, just the average estimates for each group. So the first column tells us the average estimate, and the second column how close to the real number it was. And this is interesting, right? The worst numbers come from developers, the people with the most technical knowledge of how to actually execute this project, right? And they were off by a lot. They were not even at 30%. So you know how they tell you to multiply your number, your estimate by 2 or by 3? Yes, do that. And that is if you're like an average developer. If you like fancy yourself that you're like an optimist, multiply by 5 maybe, I don't know. Interestingly also, teams gave better estimates. So maybe we are better in teams than we are individually, right? So this is a friendly reminder, never again in a project in your professional capacity say out loud, how is this project taking so long? It feels like it can be done in 600 hours, but it will actually take 4 times as long. One of the most interesting observations was that people with non-technical background came up with better estimates. Basically, the technical knowledge we as developers have compels us to underestimate the effort. Because we are really good at creating code, right? So if you ask me, can you write this and this software solution for you? I'll be like, yeah, I can see it. The functions, the classes, the files, yeah, I can see the logic. It's gonna be amazing. But what I don't picture is debugging or the specification changing or any of the testing or talking to users about it or any of that. We forget all of the things around our main solution that have to be done before this can be deployed. It was the people who talked to customers who gave the higher numbers. Maybe because they are the ones who go out face to face, meet with customers, and they're the ones who have to say, so it's going to be another month, I'm so sorry. So maybe they just think, let's multiply the developer numbers again, just to be safe. Because when you're talking to customers, it is always better to under-promise and over-deliver. So maybe just multiply those numbers again. And the same pattern was observed in other studies, in studies that look at how people perceive risk. So this study also has a very nice title, Timid Choices and Bold Forecasts. What they observed is that people can have an inside view on risks or an outside view on risks. An inside view is when you concentrate on the details of the project, on the plan and the obstacle. You're like creating steps of how you're going to reach the goal, and you're focused on the future. But this tends to produce over-optimistic results. An outside view turns out to produce better results. That is when you focus on statistics, on the past, on other similar projects that have already been actually completed, and how long did those take, and how risky were those. And this just produces more accurate estimates. Let me mention one more risk-related research paper, because this one really surprised me. This was an experiment looking at how risk is assessed specifically in software projects. This experiment was done 4 times in 4 countries. It was 180 participants who were collaborating. So this is not a fluke, right? Each time, the researchers would get a group of software professionals, most of them were developers, but not all of them, and then they would give them a hypothetical project. And then they would ask them to identify risks, what could go wrong on this project. And after they had the list of risks, they would ask them to estimate the project. But there was a catch. Half of the group was given substantially more time to come up with the list of risks. They were encouraged. What about more risks? Think about more risks, right? And here are the results. It turns out that the more the participants thought about risks, the lower their estimates for the project were. Pretty counterintuitive, isn't it? So the more risks the developers identified, the more optimistic they were about the project. This could be down to illusion of control. When we list risks, we feel like we could handle them, because unknown problem, that's better than an unknown problem, right? Or it could be that we just judge the project by the last risk we added, right? We start with the worst things that could happen, and then we add lesser worse things. And at the end, we just add minor things, and then this gives us the feeling, this whole project is just minor things, we can totally handle that. Or it could be it's when we struggle to add more risks to the list, our brains interprets this as, there are no more risks. I have thought of everything, and there is no possibility I could have missed anything, so basically risks are rare, and nothing bad's gonna happen, so let's just go with the project. So generally, you would think listing risks before you start a project is such good practice, right? Maybe it's not, maybe it is. We should think about this more, right? And one more detail, this project was eventually executed, and it took that company 700 hours. So way more than any of the groups in any combination ever estimated, way more. But there's another powerful reason for over-optimistic developer estimates that I would like to emphasize, and that's the social component of it. So if you're a developer and you're asked, how long will this project take? There are 2 constraints that guide your answer. Firstly, you cannot say, you cannot give an extremely big estimate. You cannot say, this is going to take 3 years. Obviously, nobody's going to do a project that's going to take 3 years, generally speaking. But secondly, you also cannot say give a very wide answer. You cannot say, I don't know, somewhere between a week and 3 years. That's also not going to be accepted, right? So providing either a very wide estimate or an unexpectedly big one, both are considered the same as giving a useless estimate, right? I still very vividly remember an event from my past. So I happened to be assigned to this project where we had to replace something that was very crucial to our app that was already pretty old. So it was like the basement of the app. You had to be really careful at changing it. The thing is that it was blocking our new features. It was slowing us down. So the whole development team knew this needs to be replaced. But of course, it took time to get the okay from management to allow us to replace it. And at the beginning, I could just start working on it and doing it, whatever. But then after a few weeks, the management was like, we do need an estimate. You can't just work on this forever. So I opened my computer, I looked at the form where I had to put in the date, and I was like, okay, I'll just pick 6 months into the future. In my mind, this was already pretty optimistic, but let's say we can just do it in 6 months. My manager looked at it and said, no, that's not okay. If you say 6 months, this project is going to be canceled. And developer team was like, no, we don't care how long it's going to take, we will do this. So he looked at me and said, could we do it in 4 months? And I was like, oh, I mean, sure, if like we cut corners and we just do the basics and nothing else, I guess, maybe. So obviously we put 3 months into the form and saved it. Because we had to save the project, more important than to give it like an actually a correct estimate. And the same thing was seen in research. Developers admitted to researchers that they believe their managers will see them as less competent if they provide estimates with huge margins. So to test this thinking, an experiment was created in which they asked 37 software professionals who did do some project management in the past a few questions. They gave them 2 hypothetical developers, developer 1 and developer 2. And then they gave them 5 hypothetical projects. Developer 1 always gave very narrow estimates. This person would always be like, it will take this much or this much, right? Developer 2 always gave wide estimates. And because mathematically speaking, giving wide estimates means you will be correct more often. It's just, right? If I say this project is between a week and 3 years, it's probably going to be somewhere in between, right? So that is why developer 2 was correct in this hypothetical scenarios 4 times out of 5, whereas developer 1 only 3 times out of 5. But then the people were asked the following question. As a project manager, would you prefer the estimates of developer 1 or developer 2? 35 people out of the 37, that's 95%, said they liked developer 1, even though objectively speaking, he was correct less often. And then there was the next question. Do you believe developer 1 or developer 2 knew more about how to solve this task? 80% chose developer 1, even though, again, objectively speaking, he was correct only 3 times out of 5. And you say, okay, but the other 20% chose developer 2? No, only 1 person chose developer 2. The others said they can't tell. So we prefer to have exact numbers, even if that means they're wrong most of the time. We like certainty. We like somebody to know what they're doing, or at least pretend they know what they're doing. So self-confidence, that's the key to success. And obviously we're not rational beings, right? But pretty emotional ones. So generally there's 2 distinct approaches to how you can estimate a project. You can either ask a human expert for her basically opinion, right? Or you can build yourself a mathematical model and condense the requirements of the software project into only the relevant parameters so as to give out the actual number of how many days this was going to take. And these 2 approaches might seem radically different, but basically the second one, the mathematical one, is just like a formal model of the first one, the human one. It's trying to reduce the expert's decision-making into a formula because we feel like people are not reliable enough and it's hard to port them onto different projects, right? Ideally, we want it to be like, you have like a form and you put in 5, max 10 parameters and then it just spits out the exact number. It's going to take 3 months, 2 days, and 5 hours. And then you can use this on this project and every project from now until forever, right? That's our ideal. Because we feel like everything that's human is too flawed and too biased, whereas everything that's from a computer is not flawed and not biased at all, which of course is nonsense. Every survey ever has already proven that we have absolutely no problems to put our own biases directly into the code. But still, we try to transcend the human, try to do something better. So here are the mathematical models. There's an incredible variety of them. There's regression-based approaches. That's when you're trying to create a formula, like epsilon is x plus whatever. Or there's classification in regression trees. That's when you have a decision tree, and every node is a question, and then every branch out of the node is a possible answer. And then you traverse the tree, and you come to a leaf, and that is your answer, your prediction of the future. Or you can have neural networks, which are just like a huge directed graph where you teach it to return a certain output given a certain input. And then you give it a new input and just believe whatever it spits out, right? Or there's Bayesian statistics. That's when you're dealing with probabilities. I know this is going to happen, so what's the probability of something else happening? And this one's interesting. There's lexical analysis. So you analyze the words that appear in the specification, and then you try to predict the future based on that. And then there's a million of other systems that you could technically use. But when we're building these mathematical models, what we're doing is we're often pretending to be searching for a law of nature, like a natural relationship between code and time, which is independent of the organization that is making the project or the customer that we are making this project for. But it turns out this never works. Research tells us that the best mathematical models are those that are highly calibrated to the team that they are measuring. And by calibrated, I mean that the function for calculating is based on the data that this team produced in the past. So this is experiences, right? So first, what you need is a stable team. No hiring, no firing ever again. Then you need to figure out what this team does. You need to split their tasks into the smallest possible tasks imaginable. You have to categorize them, measure everything that they do, how often they go to the toilet if need be. And maybe that's an important parameter, I don't know. And then you build yourself like this huge data that you can put your mathematical model to teach it on this data, right? And this is basically back to experiences, right? If you have done this project before and you have measured it, then you will be able to estimate accurately how much time it will take you to do it again. Producing a good model for your organization may legitimately be just too complex and too time-consuming. The biggest issue is how to get the contextual information that is currently in your coworkers' brains into the model. And the biggest question is which data that even is, right? And this is the linchpin of these mathematical models, the input parameters. And we just don't know what to use as input. So we often use parameters that will only be known after the project is done. Most commonly, it's lines of code. Or we use very subjective metrics like function points. How many function points will this project produce? One reason why input parameters often fail is because they weren't defined precisely enough. So let me introduce you to a very interesting paper from 1994, a long time ago. And this paper emphasizes that measurements in software should have a scientific basis. Metrics need to be defined in an empirical way. A metric has to be defined together with the procedure for determining the value. It is not enough that you say the project can be small, medium, or large. You must also define how will you measure what the size of the project is. Like if the metric is lines of code, if I count the lines of code, or you count the lines of code, or any random person of the street counts the lines of code, they have to come up to the same number, right? And this number has to be interpreted as the same size of project. And obviously, this means that the formatting must be completely clear. And then there's a bunch of other stuff that would need to be very, very clear before we could entertain the idea of using lines of code. But even if lines of code could somehow be precisely defined, and honestly, I don't know that it could be. The underlying problem is that you can only know this after the project is done. The problem is that people build these mathematical models on top of old software projects. And for old software projects, a bunch of stuff is known that is just not known at the beginning of the project. And we kind of know, okay, we can't use lines of code, right, to estimate the project. But then we replace one guess with another guess. Maybe let's use function points, which express like the amount of functionality this code will produce to the user. But that's not scientific. So we don't know how to estimate the project's deadlines, so we try to estimate the project's lines of code. But we don't know how to do that, so we try to estimate the function points. But we don't know how to do that, so let's just try to read the specification and find certain words in there. But we can't trust that, so we're going to build ourselves a list of synonyms and maybe use those as well, right? But we can't really rely on that. So we just go on and on, replacing guesses with new guesses and hoping eventually it will increase the accuracy of our estimate. Unfortunately, for every mathematical model, there are some studies that are praising it and other studies that are very much trashing it. Mathematical models don't seem to perform any better than human models. And the more I read about them, the more it felt like I'm reading about nutrition. Which food should we eat? Fish is really healthy, except for the mercury, it's going to poison you. Vegetables, very healthy, except for the pesticides, they're going to poison you. So which model should be used? Maybe none. Because it turns out that mathematical models are a really great research topic. But I could not find evidence of a company using them, actually, in their actual production process. These models are created and tested and researched and compared, but nobody's actually using them. We developers in our day-to-day, we use gut feeling. Just most companies, if not all of them, just use the human expert approach. So how does the human approach work? So there's two things that have to be taken into account: the size and the complexity of the project, and then the resources provided to the project, right, the team. Unfortunately, both of these are very hard to assess. It would be great if I could say, I have 4 developers and a project of size 72,000. How long will that take? But what is 1 developer? Surely a junior developer is not the same as a senior developer, right? Or surely a new hire is not the same as somebody who's been with the company for 5 years and has built the code base from the beginning, right? Or what if this is a project that's very about time zones? So surely somebody who's done time zones before is not the same as somebody who has never heard of them. And then what's complexity? Like if I compare a form, an HTML form with 3 input fields and one with 1 drop-down field, is that the same? Is that the same, or is one harder than the other? And then if I compare this to like a GraphQL mutation, is that the same, or is it more, is it less? So how do we come up with these numbers? But let's say we do. Let's say we say, okay, one form is 5, and one GraphQL field is 10 of whatever. This is still not in days, right? We have to figure out how many days is this project of size 72,000 divided by 4 developers. So somebody needs to specify the relationship between the number of people and the project size, and then people, size, and time. And how many hours does an average developer work? I mean, officially 8, right? But obviously you don't write code all day long. You do have to go to meetings, you do have to review other people's code, you do have to talk to people, explain stuff, write documentation, do whatever it is that you have to do. So basically we have 2 choices. We either spend a very long time putting these 4 and this 72,000 into some sort of perspective, some sort of official structure, or we ask a human to feel it. They'll be like, these 4, it's going to take them 3 months, 2 days, and 5 hours maybe. And that's how we go along, right? But of course, life is a moving target. As you do the same thing over and over again, you get better at it and faster. But then the world around you changes. There's a new Python version, so you have to go back and upgrade stuff, right? Or there's a new tool, and everybody's using it, so you better start using it too. You can't stay static, right? Because you have to change as the times change. And I haven't even brought up like big changes, like what if you have a customer who's really unsatisfied with everything you produce and you have to redo stuff again and again, right? Or what if you lose a member to your team, or even get a new member, you have to onboard them, that takes time. Or what if you have a disruptive team member? They're really great with time zones and you really need them, but they don't get along with anybody. Or what if there's a new law? You didn't count to include the new law and the things that you have to do now that you didn't do before. It's like a never-ending tug of war. We are trying to stabilize the world as the world is changing under our feet. And if you're a creative person, good luck to you, because creative people tend to take on ever different projects, or they take on the same project, but they solve them in ever different ways, thus completely sabotaging themselves at ever being able to estimate anything in the future. Okay, so what can we then actually do? I think the first thing we need to think about is, why are people even asking this question, how long will it take? Because they don't have the resources to work on this one project forever. And this is a reasonable consideration, right? But if the goal is to minimize the resources, let's just make the project simpler. It doesn't matter what we're building. It could be simpler. We could just make it less user-friendly, less error-safe, less pretty, whatever. We could make it simpler. If we boil down the project to the minimum, it will be done faster, thus cheaper. Here's the catch, though. People don't want the cheap software solution. What they actually want is the best that they can get for their budget. Which means the true question isn't how long this will take, but what can you build me for this much money? So since it was never about the time, but about the money, let's flip the problem upside down. We will always be bad at estimating because that's like predicting the future. Nobody can do that. So let's embrace this limitation. People are usually forgiving with delays as long as they're small delays. A delay on a software project of 2 days, nobody bats an eye. Even a delay of a week, generally not really a problem. So let's only ever estimate small projects. How could we get to only small projects, right? So instead of diving deep into the whole project and measuring the total time it will take us, let's split up the project into smaller projects and let's just estimate those smaller projects and do them. Let's build the big project iteratively. Let's first organize the priorities, the tasks by priority, right? Some things are core and other things are optional. And then let's build the core. And after we've built it, if we have time and money left, we can continue and organize the rest of the tasks by priority and build the next most important tasks. And after that, if we still have time and money left, we can continue. And after that, we still have time and money left, we can continue and do this, this dance forever and ever. That is why Agile was really so popular. So here's an example that I also want to emphasize. Let's say I'm a freelance developer and I'm just making small web pages, and a customer comes to me with 100 pages of spec, exactly what they want, and they ask just of me to estimate it. Just tell us how expensive this will be. It is hard for me to figure out if this is a good spec. I don't know if they thought of everything, of every weird situation that can happen. I don't know if all of it is even doable. But fine, let's say that I will drink the coffee, do some push-ups, I'll come up with the numbers, and I'll say this much. And they come back and say, that's too expensive. Could we maybe cut these 20 pages? Because they already know those are optional. This doesn't really help me much, right? Because I don't know how much are those 20 pages. So I have to estimate those 20 pages. And surely that is easier than estimating 100, right? So I come up with a really precise number for those 20 pages. It's going to be 15 plus 7 days. The thing is, my original estimate was pretty wonky, right? It was not precise. So even if I subtract a very precise number, the precision does not increase. The result will still be wonky. So it is much easier to start off with something that's simpler, something that's similar to what I've already done in the past. I know how it will behave. I know the problems I'm going to face. I know how I'm going to deliver it. And then we add on top of it as we go along, only the features that we feel like are really necessary. Okay, but what about projects where we cannot split them up? Because those projects exist. For instance, if you want to migrate from version Python 2 to 3, you have to do all of it or nothing or something, right? The answer is simpler, however, very unpopular. We don't know. I'm very sorry, but we don't know. We have no experience doing it. But here is a list of risks that this project takes, and here is a list of advantages that this project brings. And one of the things on the list of risks must be that we will start this project and we'll invest some time into it, and then we will change our minds and we won't want to finish the project. And we have to have this conversation at the beginning of the project, and we have to accept the possibility that maybe this will be wasted time. Because there's no point in continuing a project if we already know it's not going to work. Just because we've already invested 20 people months into something doesn't mean it's worth it to invest another month if we know we don't like the project or it's not going to be useful for us. But if we do like the project, then let's assign a person to it, just a few hours of their time, a week maybe, and then they can research a bit. That's iterative, right? And if it goes well, we can give them more time or more resources, and then we can make the project bigger as we go, or kill it at any point if we don't like it anymore. And then there's another question. what are you going to do with my, I need 25 hours? If you're asking your developers how long this will take because secretly you're going to send this number to the customer as a binding offer, I suggest not doing that because developers in companies generally are not there to haggle with the customer, how much the customer is going to pay the company, right? That makes no sense. If you're like a middle management and you ask this question to offer your developers because you are going to pass this number to your managers, maybe also only asks for projects that are similar to what they've already done, because otherwise you are going to get made up numbers. And it will be hard to explain these numbers later on when it turns out that they were made up all along. If, however, you're the person who has to come up with the number because the customer is asking you and you have to haggle with them, I suggest going with the iterative solution. And also to be very, very transparent about that you really don't know, but you can come to a good solution together, because at the end of the day, what people really want from you is to be transparent about how this project is going to go. People don't like surprises, or at least they want to know about surprises as far in advance as possible. So estimations are tricky. Don't use them just because you have 5 minutes of time. Use them when you're actually trying to mitigate some sort of risks. I know this is a hard pill to swallow, but just because we wish we could estimate a project doesn't mean it will be able to do so. We will be able to do so. I know we've set up a whole world and the IT business and everything that where we want to have numbers and we want people to give us exact times and exact budgets. But how often are those promises about budget and time really upheld? Like how many bridges or libraries in your city or your country have ever been built on time and within budget, right? Or have you ever renovated a house? Did you really expect the works to be done on time and within budget? Did you not just expect that everything is going to go over budget, right? Or if you need something from bureaucrats, and technically it says it's going to be done in 24 hours, maybe it's not going to be, and there's nothing you can do. You submit the papers and then you wait. And you wait for however long, and you expect to wait, and you're fine with that. I mean, a bit angry, but you know, fine. I, for one, I'm always really surprised if any sort of project is finished on time. I'm very pleasantly surprised, but very surprised if that is done. And I have to yet find a contractor who will give me a deadline and not just say, oh, we'll start works in June, and you know, then we'll do it, yeah. You never really get numbers from these people because they know, and we also know, right? Okay, let me mention one last study. This is very interesting as well, at least to me. This was a study done in 2022. They looked at 4,677 IT projects in 870 companies and 100 government institutions in 66 countries. So this was not a small study. They wanted to figure out if the relationship between estimating costs, between the estimated costs and the actual costs, if that was normal distribution or not. If this thing did follow normal distribution, then most values will be clustered around the average. And crazy outliers will be extremely rare, and then everything that I said today is completely irrelevant and it doesn't matter at all. Because those outliers are so rare, we don't have to even think of them. But of course, they found out that the relationship is not normal distribution. It is so-called power distribution. And this means two things. Many projects are done reasonably within the estimated time, right? But a significant number of projects are extremely over budget. And this is called the fat tail of the distribution. With a normal distribution, the more projects that you measure, the more the average settles down. You estimate 50 projects, then 100, then 200. And at some point, the average overdraft, or the average amount of time that it goes over the budget or whatever, it converges to a number. And extreme outliers are extremely rare. But with power law distribution, the more projects you look at, the more likely you are to hit a catastrophic that blows up your average. The average cost overrun for the project in this study was just 80%, so that's not that bad, right? But the worst offender was 28,000 over budget. It was estimated to 1,500, and it cost almost $500,000. Extreme overruns are unavoidable, and you cannot estimate your way out of them. So what do we do with this information? Well, this is yet another reason why building in small iterations is the only way out. If you're constantly reviewing what you're building and checking your decisions, then you can discover if something goes awfully wrong, and then you can stop it. And this study does explicitly mention also people who have lost their jobs or have bankrupted their companies because an unexpected software project could not be ended. You can't predict which project will blow up. So the next best thing is to monitor and react quickly. And so at my current stage in life, I find that everybody involved in a project is much happier if we go through the project in iterations. We don't have to decide everything at the beginning. We should first concentrate on the essential bits, the things that can be done in a few days, a week, maybe 2 weeks, a few weeks at most. It is much less risky to see somebody spend a few weeks on a project than to wait for them months and then see that the project went in the wrong direction or whatever else went wrong. And this is great for project managers and for developers, because whenever somebody has a crazy idea, you could say, that's going to be milestone 2, and that's going to be milestone 3. And they feel like their concern was registered, but you don't have to actually create it. So maybe it's time we stop estimating tasks left and right and instead start managing project's risk and the customer's expectations. People just want to be kept in the loop. That is what makes them happy, and that is how they feel they still have control over the project. So all the research that I've mentioned is accessible with links on this page, if you want to send them to your managers. Also charts, everything else. So spread the word, because I really feel like we should stop estimating stuff left, right, and just be honest about how we're really not that good at it.
Perfect. So, I selected 2 questions for you.
Yes, please.
The one is, can DORA metrics related to the accuracy of estimates of a team? Can DORA metrics related to the accuracy of estimates of a team?
Well, technically, it could, but then, as we saw, since it's a power law distribution, extreme overruns are unavoidable, and you cannot know which project that will be. So statistics is great, and it's definitely improvement over just like using your gut. But one question, do you have stable teams, or are the teams changing? They're changing, right? So you don't have statistics. But if you have stable teams, it's still a power law distribution, so weird projects will still happen. They can help, sure, better than have statistics than not, but I don't know. Just use them, but understand that they're not a law. They're just a suggestion for how long the project might take, possibly.
So then the other one. How does the rise and adoption of AI impact project estimation? For example, many tasks for junior developers can be adjusted quite fast.
Well, I find that AI brings more uncertainty, not less, because the thing can, sometimes it works really well, and other times it doesn't, and you can't know which one is going to be right. Sometimes it really does the project 80% well, and you're like, I just need the other 20%, but it's actually the other 80%. I find that, if anything, AI just muddles the waters more, isn't really helpful. But maybe if you have good experience with it, convince me otherwise. I'm skeptical. I haven't seen it.
Thank you, Ines.
Yeah.